Yeah, we're going to talk about uncertainty, and it's not kind of indecision about whether you like the data or not. It's a way of quantifying how sure you are about a number. So let's have a look at this bird data. So someone's measured these 4 types of birds. Now, they wouldn't have counted every single bird of the population. They would have done some kind of sampling method from which they would have derived an estimation of what the population of birds are in, I don't know, whatever island or whatever it is. And along with that, they've been able to give you an idea of how certain they are about those numbers. So if you look at the cassowary, it looks like that maybe they had a really good sampling method. Cassowaries are very large birds. They're on the ground. They're probably easy to find. There's probably not that many of them. Maybe you could count a much larger sample of the population, although it still is an awful lot of cassowaries there. Whereas obviously the Goulian finch, whatever their sampling method was there, they're not really sure. Like it's 50% of that could be a margin of error. So how do we represent that in a graph? Well, the first thing we'll do is we're going to create ourselves a graph here of the population of these birds here. So let's just get ourselves a graph here. Yeah, just a simple one like this. Here you go. We've graphed the birds, but it doesn't reflect the level of uncertainty. And if I was trying to look at something about the populations there, how sure I am about those numbers is an important thing. And that's what we're going to look at here in a very simple way of representing that on a graph called error bars. And we're going to show how to do them. Okay, so we go up here. So we need to be in chart design up in Excel. We go add a chart element, error bars, and we want to go down to the more error bars option here because we want a little bit more control. We could put in a fixed value. We could say, oh, well, it's plus or minus a certain percentage, but as you can see, the different sampling methods have different levels of certainty. So we're going to come down here to custom, and we're going to specify our values. All right, I'm just going to specify that next row for both the positive and the negative values. So it's plus or minus this amount. So, this is the population estimate. It could be this much, or it could be this much. So what we're saying is it's plus or minus this amount. So that's what we need to graph in our graph. Now we would need to go and write those formulas. So if there's 7% uncertainty here, then it's going to be 3.5% bigger or 3.5% smaller. So I'm going to start with an equal sign like you do in Excel. 0.5 of so asterisk times the 7%, okay, and then times the total number. So I'm saying that it's 3.5%, whatever. What's the number of 3.5% above, and what's the number of 3.5% below? I press enter, and then I'm going to drag that across. And as you can see now, automatically on our graph, the error bars are there. And you can see the Goulian finch error bar, even though it's quite a small number of finches, is representing that higher level of uncertainty. And you can see the cassowary's got a very small, or relatively smaller level of uncertainty in the number.